Hello everyone. Today I am starting chapter solutions, and in this video I'll be telling you about solutions, types of solutions, what are saturated, supersaturated solutions, what do you mean by solubility, what are the factors affecting solubility, and Henry's law. Let's start with term solution. The solution is a homogeneous mixture of two or more pure substances. It is quite possible you are having one solution having two or more solutes mixed in one solvent. And when we are talking about the solution having only two component, one component which is less in amount, which is called as solute, and the one which is having large in amount, which is present in large amount, is called as solvent. So the solution, when it is made only with the help of two components, such solutions will be called as binary solutions. And here we are talking about particularly true solutions where the particles are uniformly distributed all over the solvent, and typically the one which are having one solvent and one solute. Now, what do you mean by the types of solution? Now, what all are the types of solutions? On the basis of the state of solute and solvent, we have 9 types of solutions, and you are seeing right here the 9 type of solution, where let's take first one, where you will see solid solute is dissolved in liquid solvent, example seawater. Solid is present in solid like alloys. Solid is present in gas, it is iodine in air. Like when when liquid solute is dissolved in liquid solvent, example gasoline. Likewise, we have 9 types, and these are the example of these many types of the solutions. Now let's talk about the capacity of solution to dissolve solute. Suppose we are adding one solute into the solvent and we are making one solution. Initially what will happen? It will dissolve readily. But gradually, on adding solute more and more in amount, the dissolution will start reducing. If we continue the addition of solute, the dissolution will stop at one point of the time. That point of the time where the more solute will not be getting dissolved, that point is called the saturated solution has been made, and a dynamic equilibrium can be reached where the number of solute molecules leaving the crystal to pass into the solution, and it is equal to the number of returning from the solution to the crystal, or you can say rate of dissolution is equal to rate of crystallization. So the saturated solutions contain maximum amount of solute dissolved in a given amount of solvent at a given temperature, and the solution containing greater than the equilibrium amount of solute is said to be supersaturated. Such solutions are unstable solutions, and the precipitation occurs by the addition of tiny crystal of solute, and the supersaturated solutions will turn up into saturated solutions. Now what do you mean by solubility, and what all are the things which are depending on solubility? Solubility of a solute, it is a amount per unit volume of saturated solution at specific temperature. I repeat, a solubility of solute, it is a amount per unit volume of saturated solution at specific temperature. The solubility of solute is its maximum concentration and expressed generally in mole per liter. Now, what all are the factors affecting solubility? It usually depends upon the nature, upon the solvent, on the temperature, and also on pressure. Now, number one, nature of solute and solvent. Generally, the compound with similar chemical character are more readily soluble in each other than those which are having different chemical character. Like we used to say, like dissolves like. For example, substance having chemical intermolecular forces are likely to be dissolved in each other. Polar solute dissolve in polar solvent. This is because in these solute-solute, solvent-solvent, solute-solvent interaction, all these interactions are very much similar in terms of their magnitude. For example, sodium chloride will readily dissolve in water. The strong ion dipole interaction of sodium ion and chloride ion with water molecules will be seen here, and hydrogen bonding between the water molecules and ion-ion interaction between sodium and chloride ion are very much comparable. That is why sodium chloride readily dissolve in polar solvent, and sodium chloride is polar molecule. Non-polar organic compounds readily dissolve in non-polar solvent like benzene, right? Then another effect is effect of temperature. Solubility of substance change with temperature. It usually depends upon the enthalpy of solution. Enthalpy means heat. Many solids, for example, let's take potassium chloride, dissolve in water by endothermic process. That is with the absorption of heat. When temperature is increased by adding heat into the system, the solubility will increase according to Le Chatelier principle. And on the other hand, if we are taking example like we are dissolving lithium sulfate monohydrate or calcium chloride, they are dissolving in water, and this is the exothermic process. So effect of temperature is different with different compound dissolving in water. It is not similar unanimously for every compound which is dissolving in particular solvent. For example, let's see this graph. This graph is plotted against the solubility and temperature. If you see the solubility of sodium bromide, sodium chloride, potassium chloride changes very slightly with the temperature. Almost straight line we are seeing, right? But when we are seeing potassium nitrate, when we are seeing sodium nitrate, they are increasing appreciably with increasing temperature. Whereas if you are seeing sodium sulfate, if you see sodium sulfate, its solubility decrease when we are increasing temperature. And I can also say here the solubility of gases in water usually decrease with increase in temperature. When gases are dissolved in water, the gas molecules in liquid phase are condensed, and the condensation is an exothermic process. So the solubility of gases in water must decrease as temperature is raised. Now, effect of pressure on solubility. Pressure has no effect on the solubility of the solid and liquid as they are incompressible. However, pressure greatly affects the solubility of gases in liquids. Solubility of gases increases with increasing pressure, and the quantitative relationship between the solubility of gas in a liquid and pressure is given by Henry law. So what is Henry law? According to Henry law, the solubility of a gas in a liquid is directly proportional to the pressure of the gas over the solution. If S is the solubility of gas in mole per liter, P is the pressure of the gas in bar over the solution, we can say S is directly proportional to pressure, and after removing this proportional sign we will be adding one constant which is called as Kh, and it is also called as Henry's law constant. And if I want to deduce the unit of Henry's law constant, it would be mole per liter per bar. And when I am saying I am applying 1 bar of pressure, and at that 1 bar of pressure the Henry law constant is becoming equal to solubility of a gas, then Kh is the solubility of a gas in a liquid when its pressure over the solution is 1 bar. This is how we will define it. Now There are some exception on to Henry's law. Gases like ammonia, carbon dioxide do not obey Henry law. The reason is these gases used to react with water. Like ammonia is turning up into ammonium ion and producing hydroxyl ion, and carbon dioxide dissolved to get you carbonic acid. Because of these reactions, ammonia and carbon dioxide gases have higher solubilities than the expected by Henry law. Thank you.